So this is section 1.4, measuring angles. So the first thing we're going to do is we're going to look at these various angles. So can you look and tell if any of these are congruent? So no, you can't look and tell. You can estimate that they might possibly be congruent. So one of the things that you'll need is you would need to know if they were congruent. They would have this symbol. So angle A would be congruent with angle F. Or another way that you could tell if they didn't have it marked is you could get a protractor or you could use some tracing paper. So that's a couple of the ways that we'll be able to find out if angles are congruent. So what is an angle? An angle is formed by two rays with the same endpoint. The rays are the sides of the angle and the endpoint is the vertex. So how do we name them? So the vertex in this angle is A. So we can call it angle A, or we can also name it using 3 points. So this could be angle BAC or angle CAB. Notice that A, which is the vertex, is always the center. Or another way we could name it is angle 1. So you would just write angle 1. And that would be how you note it. So the interior of an angle is the region containing all of the points between the two sides. So this area right here. The exterior of the angle is the region containing all of the points outside of the angle. So let's take a look at how to name the angles. So it wants to know how to name angle 1. So angle 1 is right here. So I can call it angle 1. I can also name it angle JMK. I can also name it angle KMJ. So KMJ or JMK. Notice that M is the vertex point and it is in the center both times. Now let's see if we can come up with some other names for angle KML, which is right here. So we can call it KML, which it already did, or we could also name it angle LMK, or another name for it would be angle 2. So would it be correct to name any of the angles angle M? No, it would not, because you don't know which of the 3 angles that are located here it would belong to, because angle M can be JML, angle M could be JMK, angle M could be KML. So M would not work. So as we see right here, angle A is equal to 62 degrees. So to write that notation, you would write a lowercase m, angle A equals 62 degrees. Make sure you put the degree symbol, because later on, like in our class, we're only going to deal with degrees, but later on when you're in trigonometry, you'll deal with degrees and with radians. So, and the reason we do degrees is because how many degrees is a circle? So a circle is equal to 360 degrees, or a circle has 360 degrees. So 1 degree is 1 divided by 360th of a circle. Postulate 1.7 is the protractor postulate, which is very similar to the ruler postulate that we learned earlier. So we have ray OB and a point A on one side. So ray OA, it just means that there's a number on the protractor for no matter what value, no matter what our angle is. So let's pretend that this red line is ray OA. So it's saying that no matter where I move this, there will be a number that we can find on the protractor. So no matter where it is. So now we're going to look at the types of angles. So any angle that is less than 90 degrees but greater than 0 is going to be an acute angle, and it generally looks like this. A right angle is going to be 90 degrees exactly, and it will always have that little box right there. That is how you know that it's 90 degrees. Never ever assume just because it looks like it's 90, if it doesn't give you that box, you cannot assume that it's a 90-degree angle unless you measure. The other type is an obtuse angle. So this angle is greater than 90 degrees, but less than 180 degrees. And then we have our straight angle, which is equal to 180 degrees. Okay, let's see if we can find the measure of angle LKN. So that's this angle right here. Can you tell before doing the math what the classification is? So LKN is going to be obtuse. And notice I have two sets of numbers on my protractor. So I'm going to use the inner numbers. You can use either. So it's the same as the ruler postulate. So I'm going to do 0 minus, and this looks like it crosses at 145. So that gives me the absolute value of negative 145, which is equal to 145, and make sure you put your degree symbol. So let's go ahead and do that one again, but let's use the other set of numbers. So let's see. If I use the outer numbers, it's 180 minus 35. 180 minus 35 is equal to the absolute value of 145, which is equal to 145 degrees. So it doesn't matter if you use the outer numbers or if you use the inner numbers, as long as you're consistent in each problem. Now let's take a look at the angle JKL. So now let's take a look at the measure of JKL. So the first value I'm going to put is 90 minus, let's see, that looks like 35. So that gives me the absolute value of 55, which is equal to 55 degrees. Now let's take a look at the measure of JKN. So when we do this one, I'm going to start with J, measure of angle JKN. n is equal to the absolute value of 90 minus 0. Notice that I could also have put, say, 90 and 0 or 90 and 180. I'm still going to get the same answer. So that is equal to 90 degrees. So angles with the same measure are congruent angles. So, and it's just like with the line segments. So with the line segments, they did the little tick mark, and with the angles, they do an arc. So if I had a, let's say it's a parallelogram, and a single arc means those two angles are the same, and then a double arc means that these two angles are equal. So, and it's the same thing with the notation. When we talk about numbers, the measure of angle A is equal to the measure of angle B, and angle A is congruent to angle B. Remember, when we're talking about the shape, we use congruent, and when we're talking about numbers, we use equal. So let's look at this diagram. So they tell me that the measure of angle GHJ is 90, and they want to know what is the measure of angle KLM. Well, I can look and I see that this has two arcs, this has two arcs, so I know that those two angles are congruent. So the measure of angle KLM is equal to 90 degrees. The book doesn't put 90 degrees. I think it's important for us to put it. So the measure of angle ABC is equal to 49 degrees. They want to know what the measure is of angle DEF. Again, I can look at the arc, and that's the notation that they are congruent, which means the measures are equal. So the measure of DEF is also equal to 49 degrees. So now we're to postulate 1-8, which is the angle addition postulate, which is amazingly similar to the segment addition postulate. So this just says that the measure of AOB plus the measure of BOC is equal to the measure of AOC. So two parts equal the whole. So now let's do an example with the angle addition postulate. So if the measure of RQT, that's this big angle, is equal to 155, they want to know what is the measure of RQS and what is the measure of angle SQT. So to do that, we're going to add up the two small pieces. So we're going to have 4x minus 20 plus 3x plus 14, and all of that's going to add up to 155. So we're going to combine our like terms. So 4x plus 3x is 7x. The negative 20 and the 14 combine to give me negative 6. And all of that's equal to 155. So next, we are going to add 6 to both sides. So 7x is equal to 161. So now we're going to divide both sides by 7. So x is equal to 23. Am I finished? No, I'm not finished. I need to plug this into the values. So to find the measure of angle RQS, which is right here, I'm going to get 4x minus 20, and I'm going to plug in 23 for x. So 4 times 23 minus 20. See, 4 times 23 minus 20, it's going to give me 72 degrees. So the notation I would use is that the measure of angle RQS is equal to 72. Now for the next one, I can either plug in 23 into 3x plus 14, or I can just subtract. I know this whole angle is 155, so I know that the measure of angle SQT is equal to 155 minus 72. So that would be equal to 83 degrees.